Hello, and welcome back to College Algebra, MAT 150. In this lecture, we will be talking about factoring the GCF, or the greatest common factor. So, the greatest common factor, otherwise called GCF, is basically the largest polynomial, or of a polynomial is the largest monomial, that will divide into each term of the polynomial. So, to find this GCF, we're going to look for the biggest number that divides into each term. We're going to look for all the common variables, and then we're going to look for the one with the smallest exponent. So each one that's common, we're going to look for the one with the smallest exponent. So that's what we're saying. So the GCF will then be both of those combined from 1 and 2. And then what we do is we put that GCF out in front of a set of parentheses, and we divide each term by what we just found, what we just put out in front. And then simplify the division. So when GCF factoring out variables, basically the exponent of the variable that you pull out is just the smallest among them. And we'll show this through the examples of exactly what we're talking about. So let's look at some of the most basic examples we can talk about. So number 1, we have 8x minus 12. So we're going to look at, so the first step was to find the largest number that divides into each one. So let's see. So we look at, this is one term, and this is another term. Okay, so we're looking at the number, the numeric part, so the coefficients basically in each one of those. So what is the biggest number that will divide into both 8 and into 12? Well, 2 divides into both 8 and into 12, but there's a bigger number that divides into both 8 and 12, such as 4. So 4 will divide into 8, 4 will divide into 12, but there's nothing bigger that will divide into both of them. So 4 is at least the numeric part of the GCF. Then from part 2, we'll see, hey, are there any variables in common? Well, in this basic example, we have an x in this term, but not in this term. So there's no variable part of the GCF. So what we do is the GCF is just that, so 4. We put it out in the GCF out in front, and we put a set of parentheses, and we basically take each term and divide by the GCF. So I put 8x over 4 minus, keep that same sign, 12 over 4. And that's it. That's the basic happening of what's going on. Now, in common practice, when you're doing this, after you find the GCF, you just naturally say, hey, okay, you found it, and you just, in your head, you say, hey, what's 8x divided by 4? And what you have is 2x, and minus 12 divided by 4 is 3. Now, it's okay to still show these steps, but oftentimes this will become cumbersome, so just going straight from here to here is often preferred. And this is the factorization. We've factored out the GCF, and we're left with this 4 as a factor, and then the 2x minus 3 is the other factor. All right, let's move on to number 2. 12x cubed plus 16x squared. So what is the biggest, so we start with the first thing again. What is the biggest number that divides into 12, so with these two terms, and into 16? Well, does 2 divide into both? Yes, 2 does, but so does 4. But if we get any bigger than 4, so say like 6 will divide into 12, but not into 16. So as it turns out, 4 is again the greatest numeric part of the GCF. And then, do they have variables in common? Yes, they do. They both have x's. So we know that x is going to be part of our GCF. We just have to find out what power. What are we actually, what's the greatest power? So that we can pull out. And so we see x cubed and x squared, and when you think GCF, you might think x cubed. But we're trying to pull it out such that it can pull out from both of them. So we can't pull out something that's bigger than what we have over here. So what's the exponent between this one and this one? This is 3, this is 2, so we pull out the one with the smallest one. So what is the GCF? The GCF is 4x squared. Then what do? We take the GCF and we divide it into each of the terms. So 12x cubed divided by 4x squared and 16x squared divided by 4x squared. We just have to remember now our exponential rules. So 4x squared still remains out in front. And then we ask, so for each of these terms that we're simplifying, we ask two questions. What's the number divided by the other number? 12 divided by 4 is 3. And then what's x cubed divided by x squared? Well, we just subtract 3 minus 2 is x to the first power, or just x. 16, then we move to the next term. 16 divided by 4 is just 4. X squared divided by x squared, well, anything divided by itself just goes away. You could also say x to the, so you think of x to the 2 minus 2, which is x to the 0, but anything to the 0 power is, again, 1. So 4 times 1 would just be 4. All right, so what about this next polynomial? Here we have 3 terms. 1, 2, 3. So question, what is the biggest, so we go through the list. What's the biggest number we can divide into each? So 6, 27, and 9. Well, can we divide, so 6 is the smallest one, so we can't try to see if there's anything bigger than 6. Does 6 divide into everything? No. This is even, but 27 and 9 are not, so 6 itself doesn't divide into it. But what about 3? 3 is the next biggest number. 3 divides into 6, 3 divides into 27, and 3 divides into 9. So we know that there's a 3. 3 is the GCF, is the numeric part of the GCF. All right, what do they have in common variable-wise? Well, this has an x squared, and this has an x and a y. This has an x and a y, and this has an x and a y. So each of them have both an x and a y in common, but we have to ask ourselves, what is the power of the x and the y's? Well, we look for the smallest exponent. So this has an x squared, so that's 2. This is just x, so it's x to the 1, and this is just x, so x to the 1. So the smallest exponent that we see from these are shared between these two, and it's x to the first power. You could write that if you want there, just to be extra clear, but you don't have to. What about y cubed for y's? What about y cubed, y to the 4th, and y cubed? Which one's the smallest? Well, again, shared between these two. So y cubed. So this is our GCF. And again, we ask, what is each one of these divided by 3x y cubed? 6x squared y cubed divided by 3x y cubed plus 27x y to the 4th over 3x y cubed plus 9x y cubed over 3x y cubed. And then, again, we don't really need to write the 1 there, but xy cubed, 6 divided, so we have to go through and simplify each of these 3 terms. 6 divided by 3 is 2. X squared divided by x is just x. Y cubed divided by y cubed cancels, so we're just left with 2x. 27x y to the 4th over 3x y to the 3rd. 27 over 3 is 9. X's just cancel. Y to the 4th over y cubed is just y. And then the last one, we get 9xy cubed divided by 3xy cubed, so 9 divided by 3 is 3. But then x divided by x cancels out. It becomes multiplied by 1. Y cubed over y cubed, same thing. So we're left with this. So this is one factor. In fact, this could be split up into 3 factors. More than that, depending on how you like to look at it. And this factor. And this factor inside has 3 terms. All right, and this is our factorization. All right, so this is one way of dealing with GCF. So sometimes you just have to go with all that and you have to find it manually. Sometimes for a GCF, it can be part of something bigger. So let's look at this first example right here. So what if you have, so let's look at this. When you have multiplication, that's part of a term. So you have x times 3 and 2 times 3. So x times 3 plus 2 times 3, these are 2 terms. And what's common in both terms? The 3 is. So what can you do with the 3? You can put it out in front. That's why? Because that's the GCF, that's the greatest thing that they have in common. And then you can just rewrite what you have otherwise without the 3. So put the 3 out in front, then what are you left with? You're left with an x and then a 2. And that's one way to think about it. But what else can we see? Well, x times x plus 2 plus 2 times x, x times x plus 1, and then is one term, and plus 2 times x plus 1, is another term. But within each term we have x times x plus 1 and 2 times x plus 1. Do they have something in common, a common factor? Well, yes, they do. X plus 1 is in both of these. So you can rewrite this as x plus 1 pulled out to the front and then rewritten with the x and the plus 2 inside, left over. So what does that mean? If we look at something like this, a squared times b plus 1 minus 2 times b plus 1. These are the two terms. What do they have in common? That's right, they have a b plus 1. And then what do we have left over? The a squared and the minus 2. So we pulled out a common b plus 1. It looks weird, but when you see it like this, it's quite simple. So we have x times x plus 2 plus 3 times x plus 2. What are our terms? This is one big term, sort of main term, and so is this one. What do they have in common? They have an x plus 2, so that's what we write in front. And what do they have left over after we pull out an x minus or x plus 2? You have an x and you have a plus 3. And that's all that's going on for these. This concludes this lecture.